I didn't wake myself up. I got woken up by 50.
Fun with that class. What's the purpose?
I've done none of my homework.
There you go. How's the grade go?
0.
You have a 0?
No grades put in.
Oh.
So technically it's
You got over
Just saying hi. Bye.
joined yet?
Oh, let me check. I don't even know what to do on that. I just made it for no reason.
I just sent answers, but that way people actually show up.
I'll send answers to the classroom.
Are you caught up?
Nah, I didn't do 1.1.5.
It's not that bad.
It's
Even
finished.
1.4.
I finished 1.4.
1 class equals 1.4.
You lose for the rest of the semester.
That's a lot. I don't start doing TNA quick in like freaking March. You know that. It's only whenever you got put at that table near the door.
What's it?
Yes. That's ridiculous. Okay. So what color are you thinking right now? Black. Yeah, that's what I got about. Bro, it gives me so many options. Like when you move in every day, bro. Yeah, because you do it when it says don't do it. It says that's a lie.
And then I'll text you.
Tell me the same. 19?
Guess who?
19? It is 19.
I'll see her in a couple hours.
After lunch, right?
Okay, if you didn't give me assignments 21 and assignment 10 last class, there's your last chance to still get full points on those. Most of you did to me last time.
Do you have another copy of number 10?
Number 10. You can check the basket over there.
Is this number 10?
Yep, that looks right.
Okay, Lucas. The text button. That's great, Lucas.
Okay.
You say 10?
Assignment 10. I just didn't take it up before. All right, so you picked up 2 more handouts on the way in. So one of those is the book assignment we have been chipping away at. So if you have been doing what I have been asking you to do, you should have about 8 or 9 questions left on that. So I will ask you to finish that up at the end of class today. But before we get to that, the other handout you picked up is number 22. And so this is another circuit like we did last class. So same kind of rules apply. But this circuit's not focused on the power rule. It's focused on the product and quotient rule. So like we did last time, I will go ahead and start you off here. Make sure that you're aware of the process, and it allows us to kind of talk about the product rule and the quotient rule again. Now, to me, I consider these patterns or formulas that need to be memorized. It would be a good idea for you to probably, I know you have these in your notes, but it's probably a good idea if you add to just the top of your paper, if you're trying to take the derivative of something times something, I'll call it u times v. If it's u times v, how would we go about finding the derivative for product rule? Okay. So v and u are obviously just some generic functions, but that's a nice, neat way to think of the formula. Okay, and then we have the quotient rule, which is when we are trying to take the derivative of something divided by something. So again, I'll say u over v. So first part of this one, the order doesn't matter, because addition, whether you add this to this or add that to that, you get the same thing. But in quotient rule, the order does matter because of the subtract sign in the numerator. So you need to take the derivative of the numerator first, denominator left alone, and then minus, then do them the other way, all over denominator squared. Now, you should, again, since you're fairly close to finish with that long book assignment, you should be very familiar with those at this point. But again, I think it just helps to go ahead and put them at the top of your page so that you can glance at them here and there. But you absolutely must memorize those. I think I've said this a few times, but your AP exam does not expect you to take a million different type of derivatives. There's only a handful of things you have to be able to do as far as you taking the derivative. Sometimes you use a calculator. Sometimes you use the power rule. Sometimes you use one of the derivatives we memorize. Sometimes you use product rule. Sometimes you use quotient rule. And you have seen all of that. The only type of derivative that you have not seen that you will have to know is something called chain rule. But again, you've seen the majority of that. In fact, did I talk about the new poster up there with y'all? Okay, so I've had this poster for years. I've never used it because I didn't have it laminated, but I got it laminated this year. So this is College Board's layout of all of our different units and what each topic is and how much it's weighed on the AP exam. I have most of this on your class website already. But like here's limits, and you can see for y'all, I've started checking off the topics that we have done. So Unit 2, finding derivative of tangent, cotangent, secant, and cosecant. I've shown you that. You haven't memorized it yet, but you've seen it. Quotient rule, product rule, derivative of cosine, sine, e to the x, and natural log of x. Derivative rules, constant sum, multiple, constant multiply. Power rule, determining when derivatives exist and don't exist, and using derivatives, derivative notation, like the definition of the derivative. So you've seen all that. So you've seen almost all of Unit 2. It's a lot of information, but you've almost got the whole second unit under your belt. Okay, so again, I wanted to just go ahead and remind you, and I want to work out question one the long way. What I mean by the long way is I'm going to work out question one two different ways. So when we do these circuits, obviously the top left question will be question one. Everybody's got to start in the same spot, so they even numbered this as number one. Now, they are specifically asking us to practice product rule, quotient rule. And again, that's why I'm giving you this worksheet. I know you did a ton of this in the book assignment, but there's no such thing as too much practice with this. So I'm thinking of all of this as U and all of this as V. I guess if you have not memorized this formula yet, one thing that may help you is to force yourself to write it down each time. If you force yourself to write out the product rule every time you use it, then of course that extra repetition is going to help it sink in. But the derivative of U would just be 2. The derivative of V, V left alone, and then switch them up. The derivative of V times U left alone. And similar to the last circuit we did, the final answer probably doesn't look like this. You probably need to simplify it, but I guess you can start looking if you want to. I'm going to suspect they probably distributed this 2, probably distributed the 3, and I'm guessing they probably did that so they can combine like terms. 12x's and a minus 1. Does that look like one of the choices? Okay. So whichever box says that as an answer, that's how you know what number 2 is. Move on to that one next. Okay, I said I was going to do this question the long way because I want y'all to also understand the purpose of this worksheet is to practice product rule, quotient rule. Get more familiar with the formula, get more comfortable with using it, just make progress from wherever we're at. But I also, just for your own sake, I want you to understand that as we move throughout the year, or even on your test, on a multiple choice question, nobody cares how you go about finding this derivative as long as you can do it. Some of you would prefer to FOIL, maybe even combine your like terms. And for some people, they prefer to do that because then now the derivative isn't the quotient rule. Product rule. It's not the product rule. It's just power rule once, twice, and knowing the derivative of the constant is 0. Is that the same answer we got? It was? Okay. I feel like it was different, but I just don't remember, I guess. So, in theory, if you'd rather multiply first and then do the derivative, you always could. Okay, so find that box, try it as number 2, and then keep on going. I'm going to put in these last couple of assignments and then agree?
Oh, yeah.
The first part of the quotient rule would go through that, correct? That's why so I like to refer to them as U and V, just because it makes the formula simpler, but they really need to be functions of X. So like, if you look in the textbook, it would probably say like f of X, g of X. This isn't really a function of X, it's just a number. So you could use the quotient rule, but you could also just move all of that up. Correct. And then the 3 would still be up front, but then you could just do, actually, you can't do this that way yet, because you don't know chain rule. But once you know chain rule, you do it in quotient rule. Yeah, let's do quotient rule. Okay, this is the answer I got for question 2, which you probably either got or realized something was off. But if you did not get that question 2, I'd be happy to go over it with you. Does anybody need to see this one worked out? Okay. So first, you have to recognize the first thing you have to recognize is why you have to use the quotient rule. You've got if something divided by something. The second thing is you have to memorize the formula. So if you call this u and call this v, the derivative of u divided by v. Again, there's no shortcuts to this. You just have to memorize the pattern or memorize the formula at least. So, derivative of the numerator times the denominator left alone minus, then do it the other way, all over the denominator squared. So, first part, I need to take the derivative of the numerator, which would be power rule. The derivative of 2x is 2, and knowing the derivative of the constant is 0. Times the denominator left alone, so times 3x plus 7, and then minus, and then do it the other way. Now I'm going to leave u alone, which is my numerator, times the derivative of the denominator. So the denominator would be 3 plus 0. The derivative of 3x is 3. The derivative of a constant is 0. So 3 plus 0 is going to be 3. And then all over the denominator squared Now, most of the time, you don't do anything with the denominator other than say it's squared, so you can see that it gets left alone. And for this question, you can at least clean it up a little bit because there's so much of this numerator that combines. If you distribute your 2 and distribute your, well, I'm going to treat this like a -3. If you distribute your -3, you would get -6x and plus 15. So the 6x minus 6x gives you 0 x's, which is why I don't have any x's in my numerator. And 14 plus 15 gives you 29. Okay, anything more detailed about question 2 while it's still up? Okay. Again, I think you guys are probably working fairly quick through this, or I hope that you are. Has anyone found one they need help with within like the first 5 questions? I don't want to take one too far into it. Yeah. Okay. I would ask you which one is 3, but I should know. This one? Okay, so just looking at the function, do you think this is going to be power rule, product rule, or quotient rule? Very good. It's x squared times cosine of x. So I can't just simplify this multiplication, so I'm forced to do product rule. And now again, I'm not going to take off credit on your assignment today, but I do think it's a mistake if you don't know the formula still and you don't make yourself write the formula down each time. The derivative of u times v would be the derivative of u times v plus the derivative of v times u. So also make sure you're using good notation here. Y equals is talking about the original function. Once you start taking the derivative, you need to start calling it y prime. So it says to take the derivative of the first part. So the derivative of x squared would be 2x. It says leave the second part alone. So leave it cosine of x. Product rule has a plus sign. And now do it in the other order. Leave the first part alone, x squared, times the derivative of the second part. This is one you have to memorize. The derivative of cosine is negative sine, and the negative sign changes as plus to a minus. And so here is the derivative. Technically this is correct. I've not looked ahead, but my guess is that they probably at least factored out an x. And I'm going to guess this is how they wrote the answer simplified. But I don't know. Does that look like any of your answer choices?
Yeah.
It does? Okay. So you've got to recognize Y's product rule. You have to have product rule memorized so that you know what the format of your derivative should be. You've got to be able to do the power rule to do the derivative of something like x squared. You have to memorize the important ones like the derivative of cosine. And then it's just a matter of piecing it all together. Okay. Let me give you a little bit of time to work. I think y'all are not got too many questions yet. Now, just a quick reminder here for our plan for today. Obviously, I'll switch back to this, but I want you to finish this up and turn it in. I'll give it back to you today. This is our first priority, and there's no way it should take you more than class time unless you're not asking the questions you need to ask.
Could you do number 7?
Yes, but maybe skip it for right now. I don't think most people are there. If you're working pretty quick and you find out that you need help on one later on, just skip it temporarily. Or it's a random question. And then, I will help you once I think everyone's made it to that point. Yeah, there's only 20 questions on this worksheet, and we've already looked at 3 of them together on the board, so. You in this class?
Do you teach this class?
Not usually.
Thank goodness.
Careful.
I'm just kidding.
Okay. I'm guessing you got a couple more ready. So which one were you asking for? 6? Number 7? Okay. You want to tell me which one number 7 is?
I got bottom right corner in the back.
Bottom right of the back. This one?
Yeah.
Okay. Did anybody else get this as number 7? Yes? Okay. That sounds right then. Okay, so they want us to take the derivative of sine squared. Now, I'm going to say that a good, I don't know if I need to record this or not. They want us to take the derivative of sine squared. I'm going to say a good probability is that it's the square that's causing you the issue here. Remember, with trig functions, this is how we square something, but what that really means is you're taking sine squared, or another way to say that is sine times sine. Now, you will have an option on how to find this derivative when we do chain rule, the only type of derivative I haven't shown you yet. That's why it's asking you to rewrite it first. So, instead of saying sine squared, call it sine times sine. So, my u in this question is sine, and my v in this question is sine. And this would be product rule, something times something. So, to model what I suggest to you. If you don't have the product rule memorized, make sure you write it out each question. U prime V plus V prime U. Okay, and then now we can do the derivative. So take the derivative of the first part, and what is the derivative of sine? Okay, times the second part left alone. So leave that aside. And then it says do a plus sign. Make sure you're careful there. Quotient rule has a minus in the middle of the problem. Product rule has a plus in the middle. Two different things. So u left alone, which would be sine, and then the derivative of the second part. So once again, the derivative of sine is cosine. So it looks like we've got a cosine x sine x plus a cosine x sine x. So I'm going to guess that they changed this to say we have 2 cosine x sine x. That's probably how they wrote it. Or, I don't know. The order of multiplication doesn't matter. So maybe they did 2 times sine x times cosine x. But one of those two. Okay. Is that okay there? Now this is completely random, but this is kind of a good math trivia question that I bet a lot of you guys don't know. When I say that the order of multiplication doesn't matter, 2 times cosine times sine is the same thing as 2 times sine times cosine. Why do you think we always put the constant in front? Like, can't you also just say it's like cosine times sine times 2? Isn't that true? How come we never write it like that then?
It would look like it's in the true function.
Right. It starts to become a problem. Is this the sine of x and then times 2, or is it the sine of x times 2? And so by putting that 2 at the end, it kind of causes some confusion. So typically that's why we put the number out front. Same idea with like square roots and stuff. Like if you had 3 square root of x, technically you could say the square root of x times 3. But if you do it this way, depending how long your square root is, it's easy to confuse. Is the 3 under the square root or not under the square root? So we just tend to put the number out front, even though mathematically it's the same. All right. Sorry, going off on a tangent there. We talked about that saying, right? Going off on a tangent? You've heard the saying before? Okay, so that comes from tangent lines. If here's your conversation, and somewhere in the conversation you just kind of go off on your own, that's going off on a tangent line. Like, it's not a coincidence, that's where that saying comes from. You were with the conversation at some point, and then you just kind of went on your own path, away from what everybody else was doing. So, what? You knew some calculus before you came in here, and you didn't even know it. Okay, is that enough for question 7? I feel like I've been here 10 minutes. Okay, does anybody have a question in the first 6? Okay. Okay. 6 is the one that has this as an answer. So I'm guessing okay, I have no idea. Where's number 6? Okay.
One below the top right.
This one?
Yeah.
Okay. And this is number 6? Okay. If you need help with number 6, please follow along with me here. As you guys know, I don't mind taking this. I love when you ask questions because I'd rather you ask than to just wait and find out the hard way later. But I don't want to work the same question multiple times. So if you need help with 6, please follow along with me. Okay, so for number 6, is this product rule or quotient rule? Okay, it's definitely going to be quotient. You've got something divided by something. So if we think of it as u over v, the quotient rule says it'll be the derivative of u times v minus the derivative of v times u all over the denominator squared, all over v squared. And don't be lazy and skip out on writing that over the denominator. I know that sometimes you have to carry that along for a few steps, but if you don't make a habit out of doing that, then that will cause you problems. Okay, so I can jump straight into the derivative here. What do you think the derivative of the numerator is? Very good. The derivative of 1 would be 0. The derivative of cosine is negative sine. We use that one so much we have to memorize it. Okay, times the denominator left alone, so 1 plus sine x. And then it says subtract the numerator left alone. So I'm literally just copying down half of this. Times the derivative of the denominator. What do you think the derivative of 1 plus sine is? Okay, cosine. And again, don't be lazy. Put it all over the denominator squared. Okay, and now technically this is the derivative, but I can see that a lot of this stuff in the numerator should cancel out with like terms. So if I distribute this one, it's going to be a negative sine x minus a sine squared x. You okay with that distributing? Okay, over here I can distribute the negative cosine, so that would be negative cosine x minus cosine squared. Denominator is just along for the ride. Alright, I think I see one more thing that we could do. I noticed the numerator has a negative sine x. I'm going to leave it alone. It's got a minus cosine x. I'm going to leave it alone. I'm probably going to leave the denominator alone. But my guess is, and I did peek at the answer a second ago, but my guess is they're probably going to do something special with these two. And I'm not 100% sure because I don't remember. So isn't there some relationship between sine squared and cosine squared? Okay. It is one of the theorems. What theorem tied those two together? Okay, and what did it say? Okay, if you take sine squared plus cosine squared, it equals 1. So if you skipped pre-cal, this is one of the identities that we use that not only do you need to memorize, you need to memorize it well enough that you can recognize it, because obviously there's no one giving you this hint at the end of this question. But I don't have a positive sine x plus a positive cosine x. I have a negative of each one. So that's like if I multiply this side by a negative 1, it's the same as multiplying that side by a negative 1. So instead of negative sine squared x minus cosine squared x, you can replace it with the negative 1. Okay, now I'm going to guess that it's probably pretty close to what they have. It looks like the only other thing that they did is they recognized every term in the numerator had a negative, and they just chose to pull it out front. But otherwise, same as what I got. Okay, so did you find your mistake in there? Okay, was it before this or was it this part? Is that, yeah. Yeah, you absolutely have to know sine squared x plus cosine squared x equals 1, and hopefully recognize it when it kind of shows up there. Now again, there's not like you have to do this every single time, but when you do this on a test, and you will have multiple quotient rule problems on a test, if you are sure you did the derivative correctly and your answer doesn't look like any of the choices, it gives you an idea of how to simplify it. So maybe within the simplifying you might need to change sine squared x plus cosine squared x to 1. It's not like it's a every problem type of thing. Okay, do you guys have any others in the first 7? I know we've looked at several of those. Okay, number 8.
Could you do number 8?
Okay, just for you though. Okay, I'm sorry. lot of other people were asking the same one. I was just kidding. Okay, so 8 is this one.
No, it's the one up, it's the bottom right.
It's the last one on the first page.
Oh, so I mentioned this on the last circuit that we did, but it didn't really happen very much. I did tell you that, you know, sometimes if you do one of these wrong, your answer will still be there. You know what I'm talking about? And that's where I was just trying to remember the answer from a few minutes ago. That's very similar to the answer to 7, I think. But it's actually, this was actually the answer to 7. So this is 8. Okay. Okay, so if I asked you to take the derivative of tangent, they're giving you a hint here. Tangent is the same as sine over cosine, and the idea is if you can think of it as something over something, like sine over cosine, we can use the quotient rule. So, derivative of the top, we memorize, times the bottom left alone, minus the top left alone, times the derivative of the bottom, which we memorize, all over the denominator squared. I'm sure they're going to say cosine times cosine is cosine squared, sine times sine is sine squared. It's funny, I feel like I just went on a rant about this. So, what does the numerator happen? Okay, 1. Technically, this is correct. It's the derivative. Technically, this is a more simplified version of the derivative. It's still not going to look like their answer, though, because they're going to do one more trig identity. What was 1 over cosine equal to? Then 1 over cosine squared is going to be secant squared. Now, technically, I haven't asked you or haven't insisted that you memorize these yet, but remember I did give you a handout. One of your notes has the derivative of all 6 trig functions. Honestly, we use those often enough that you really just want to memorize them. Just like you memorize the derivative of cosine is sine, negative sine, the derivative of sine is cosine, you really should memorize that the derivative of tangent is secant squared. But in theory, if you forgot it on a test, you could change tangent to sine over cosine, use the quotient identity, and you could figure out that it's secant squared in the moment. So you can actually derive all the other 4 trig derivatives pretty easily like this. In fact, that's what they're asking you to do on this one. They don't give you a hint, but if you want to use product rule or quotient rule, you're going to have to remember cosecant's the reciprocal of sine. You can use the quotient rule if you want to, but honestly, for longevity of this class, you really should memorize this one eventually. The derivative of cosecant is cosecant, cotangent, and should it be positive or negative? Huh? I didn't hear you. Right. How do you know it was negative? Right. If you're taking the derivative of any trig function that starts with the c, it was always negative. If you're doing the derivative of a trig function that doesn't start with c, it's positive. You might remember me giving you that much of a hint. So again, you don't actually have to memorize those. It's just long term, it's less work if you do memorize the 6 trig functions. I also teach BC now, and in BC we have to review AB stuff because their AP exam has AB and BC stuff on it. But this is one of the BC things I made them do, was we actually took all 6 trig functions and derived the derivatives. But really all you have to know is quotient rule and trig identities. So they didn't think that was difficult at all. Okay. Yeah.
What's x to the 3rd power squared?
X to the 3rd power squared, like this. Okay, well, you could either know the exponent property, or you could say anything squared is when you multiply it by itself twice. And what's x cubed times x cubed? What's x times x?
Oh,
X-
the x to the 6.
Right. When you multiply things with the same base, you add the exponents. If you raise an exponent to an exponent, then they get multiplied. So either way, you get x to the 6th. Okay, let me give you a few more minutes to keep going, and then I will keep offering help. Again, I'm going to keep switching back to the agenda, though, because, again, this shouldn't take you the entire class. I guess if it does, that's fine, but it just means you need to. I'm giving you the rest of class to finish up that book assignment. It was a long book assignment, but this is the third class I'm giving you class time to do it. So. Also, not a terrible idea to put a star by the ones you're struggling with. You remember to look back at them before the next test. How's it going?
Good.
There's nothing that has access.
Well, they might have reduced them.
We just use that.
So I think for this, how would you do it?
So yeah, it's actually for F2 times A2. So in given when it tells you to find the stage of 5, you can use F of 5 and do that. And so it just gives you what F of 5 equals, but it's not the derivative is not taken and it is like
Right here.
Okay, so right here you've got 3x squared, or here you have minus.
That's it.
would you do, oh, no, it would be F of 5 times the derivative of D of 5. So we can use the derivative.
Just combine the minus.
Okay, so what's 3x to the third minus 9x to the third?
Negative 6x to the third.
Okay, and then when you distribute that over plus 7, you get,
Minus 21x squared, and you take out negative 1. And negative 3x squared.
okay, factor out a negative 3x squared.
Oh, that's what it was, and you put the x squared. Okay, fine. And then, so, but it still goes to that one, right?
Mr. Johnson, when's the test for this?
I don't know the date yet.
Do you think it'll be like next week sometime?
Well, this is a B week, so I don't see y'all anymore this week. So if it's next week, it would be Friday. I'm not sure if it'll be.
Is there gonna be a quiz over this or just a test over the post test?
I would call it a test. But
I tried to do it like 3
I do.
I have This right here, 3x, square root of 7 over
And then I saw her and she had like,
What do I
she
do?
had two people who's like,
Well, I know this x just cancel out one of those x's.
like she's holding.
Change it to x to the fifth.
I hope she read it.
Also,
You should be trying to get this.
Mm-hmm. No, I'm just like, okay, cool.
What do I do?
I'm like good. Oh no. Yeah, I was just wrong. I'm like close.
What is the answer?
I think it's this one.
Okay, this was 21x squared.
I have 2x, x in the x root on the
So you
bottom.
could have
Yeah,
actually
I
talking
only
about
have
an x squared, not just an x.
Yeah.
And then the x squared would cancel that and make it x squared.
Jack, what you want?
Okay, I don't know. There's one I can do, so just skip it.
I can't figure out how to do this.
That's one I just skipped then.
So,
Then we can be back to it, like, give randomly.
This one?
Yeah.
yes.
Yeah.
Okay, so you did 3 square root of x minus, what do you think the derivative, well, let's just do 3x plus 7. What do you think the derivative of x square root of x is?
Is it 1/2 squared x?
1 what?
1/2 squared x?
Square root of x.
Like that?
No, but yeah, I didn't use the denominator.
Okay, good. So that sounds fine. All over the denominator squared. Okay. So it sounds like you did the quotient rule correct. But I know they're going to simplify this because of this. I've got a small fraction within a big fraction. That's a complex fraction. So how can I get rid of this divided by 2 square root of x? Okay. So multiply by 2 square root of x, so those cancel. But just like with all complex fractions, if you just do it here, then you're essentially just erasing this and pretending like it's not there. You have to multiply every term. So this term, this term, this term.
So I accidentally left number 10 at home, so is there any way you could make it like an assignment on Google Classroom that I could turn in there when I get home?
Just email it to me. That'll work.
Okay.
Are you okay with how I multiplied everything by 2? So what I really did is I multiplied the top and the bottom by 2 square root of x. Since I'm multiplying the top and the bottom by 2 square root of x, it's like I'm multiplying by 1. And in the numerator, you just have to distribute it. Okay. So then, this is the derivative. 2 times 3 would be 6. Square root of x times square root of x would be x. Those canceled, so I'm left with a negative 1 times 3x plus 7, or a negative 3x minus 7. And in the numerator, so what's square root of x times x?
Just
2x. Now we can combine these together. This is x to the 1/2. This is x to the first. So to the 3/2. So when you combine like terms for the numerator, you end up with 3x minus 7. In the denominator, you've got a 2. Now they did rewrite this a little bit. You've got x times x times x, and then the square root of that. So that reduces to 1x square root of x. Are you okay with why that turns into that? Okay. Sounds like everything was okay. My guess was that you probably didn't multiply everything by 2 square root of x to get rid of the complex fraction. Yeah. Again, it's just not common, but when you need it, you need it. So. Yeah, you want me to come up?
So I rewrote it as one for breakdown, and then the derivative of that is square, part of the quotient rule. So you can do zero there, and then
Well, that's the one we just talked
the
about.
derivative of that is sine.
Since this has a negative exponent here, you could think of putting it down in the denominator. And then if you've got a small fraction and then a big fraction, that's a complex fraction. So I just went through and multiplied everything by 2 square root of x. And it got rid of all those small fractions. So use that and then let me know if something shows up. Doing okay?
I think going, I don't understand this one. Is the business like a function, derivative, or something?
I do. So you want to know h prime of 5.
If that one's okay.
So you're going to first have to figure out the derivative of h and then plug 5 into it. So here's h. So since it's something times something, you either like write out the product rule. Square root of this times this left alone plus square root of that times that left alone. Then plug in 5 and then it's giving you the information.
So we don't, so we can just put these ones in this and like finding what just like the base derivative is, or the base function is?
Yeah. Pretty much when you do the derivative, it's just going to look like the formula. And then all that information lets you like plug in something. Thank you. We can work it out.
Because 3 squared,
Why does
because after t is on. Just because our base function is
anything I can look at?
This is number 11.
T is on the bottom, you have to put that one.
Because, I don't know if this is right.
That's fine, okay, but to make it look like the normal one, cosine squared is like cosine times cosine.
Yeah.
So you could do sine over one of the
That one
cosines,
took me forever, so I'm
tangent,
trying to simplify it as
and
well.
1 over the other cosine, that's secant.
So the
I've done this
tangent
myself,
secant.
you know?
Derivative of the secant is the secant x times tangent.
So,
You did it right. You just didn't think to split apart that fraction and think it was sine over cosine tangent, 1 over cosine secant.
alright, thanks.
Your friends is telling me to give you a hard time. Oh, I can't tell you that.
I think I have 2 friends in your classes. They're in different classes.
Well, they told me they're in advisory, so I don't know.
Advisory.
But they are in my class, yes.
Is it AV or BC?
One with the B in it.
Very informative.
Shouldn't you be able to narrow down your friends a little better now? Which
How do you think?
I don't know. Tyler just said stuff that went through my head.
not either one.
So, I mean, what I heard was like you just have to plug it in, the same one.
Yeah.
I don't know what the class is. I tried doing that, and then it gave me 6, and then I got the derivative, and I answered it, and it didn't really match up.
Just get the exact.
That's what I do when I got to it.
So,
I like it
you know
better too.
how in our notes it says like f of x is over g of x?
It's easier for me to
That
like
should be in place, so just because g of t is on top, f of t and bottom, it doesn't matter. So you can do f of t. Like that thing. Did you get, the other one that was like that, this problem, like? Yeah, it's the same thing, except they changed the letters up on you to make sure you knew how the problem
That's why I like these, because they, same exact skill, but it's really good. Yeah. So you've got h, you want to know something about h prime, so just do the derivative first. H prime is going to be
Oh,
derivative. Write it out.
This is actually
Prime, h.
That's definitely a calculus something, I feel.
Yeah.
Apply the formula.
The answer to you. Yeah.
Instead of
The question is like how do you get
No,
it?
not yet. You're not doing any of this yet. We're just changing this apart. Hit the derivative first, so F prime. Second part.
I didn't have the area.
Yeah.
It's just not like, it's already done it for you. I am a senior, so.
Now I'm moving a little bit closer and you can say, I want to know H prime, I know H prime is 5. H prime of 5 is plugging 5 into this, 5 into this, 5 into this, 5 into that. But all that, yeah, that's the information that will push you there.
Thank you. Okay, let me try that in the board. Okay, I'm getting a lot of questions about number 12, which is right here. So if you are not to this one yet, you probably want to jump ahead. What I was saying before we did our power rule circuit last class is that what I really like about these questions is they're usually very well thought out, where this is exactly the same skill as the first 11 questions, but it's phrased in a slightly different way, which can cause you problems if you really don't know the calculus very well. So first off, here's H, and at the end of this question, I want to know what H prime at 5 is. So here's what I'm aiming for. But first, you've got to figure out the derivative of H with T's plugged in. That's just using the product rule. I'm going to take the derivative of the first part times the second part left alone, plus the derivative of the second part with the first part left alone. Now, this question isn't asking about H prime of T, it's asking about H prime of 5. So if I want to know when T is 5, it means I'm going to plug in a 5 here, and a 5 here, and a 5 here, and a 5 here. And that's where the rest of this mess of stuff is coming from. H prime of 5 is 3x plus 7. G of 5 is 2x minus 1. F of 5 is 3. And G prime of 5 is 1/2. And so that's how you piece all of that together to get close to the answer. Now, you probably still need to FOIL this out, would be my guess, but again, it's the same thing. It was still product rule, and then the only difference is you're plugging in a 5, and it's giving you random information so you can see how those things plug in. But that really, other than slightly different approach, it shouldn't seem any easier or harder than the other product rule questions. So, you have a question about this one?
No.
Okay. All right, let me come over and help you.
Is that enough?
And your AP exam does a lot more of this type of stuff than the other stuff. I mean, sometimes they give you a function and just say find the derivative, you try to go or whatever. But a lot of times they like to put these type of twists on questions where you better know the product rule, you better know to apply this product rule, and then you're going to just throw in this other information in a way that maybe you've never done it before. So.
Just like boil them out and then.
Okay, why don't you take this part? I agree with this becomes this, that becomes that. It looks like you didn't take the derivative.
Well, I almost.
Oh. Close.
think what's, I think you're probably right. I'm gonna look at it on the board.
Yeah, so it's like this, right?
Apply together first.
Cause that's what I thought, but I've been looking and I can't find anything that even looks.
Probably just don't recognize that it's the same. I'm guessing that they
And then I added
just did product rule and didn't work out.
Yeah, but like there's nothing that has
So
a
let
B.
me do it the product rule way.
That's what he has to say. 2B. Oh, so you must have. Oh, that's probably, that's probably an X that, yeah. Alright, maybe. Oh, wait, sorry.
If you're gonna refer to it as F and G, F is the numerator, G is the denominator. So that's what you gotta do this backwards too.
That's why I don't like to think of it as an F and G, because some questions are going to be H or something anyway, and then all of a sudden, what? You're just adding a twist to the question. I think of it as numerator and denominator. Derivative numerator over denominator minus derivative denominator times numerator over denominator squared. And then it doesn't matter what function they're talking about.
Probably went about it the wrong way by going backwards on half a question.
Yeah, that's actually not a bad strategy also. If you guys ever do get stuck on a circuit, you can always consider trying to go from the back forward. You know what the last answers... Never mind. Forget I said anything. Okay. Are you okay with this as the derivative for product rule? So the main thing that I notice about this compared to looking at the answer choices is this one has that same denominator as the one in the top right. So that's kind of my hint that they must have gotten a common denominator here. So if this is a 1, but I would really like it to be 2 square root of x, you've got to multiply the top and the bottom by that, so it's like you're multiplying by 1. Then you can shove all this together with the common denominator. And then right here, you've got x plus 3 squared. I'll just FOIL it out. Over here, we've got a 2 times a 2, which would be 4. Square root of x times square root of x, which would be x. And then that's being distributed to x plus 3. So 4x times x. And 4x times 3. And then at the end, they're going to combine like terms. You've got 5 of those, you've got 18 of these, and you've got a constant of plus 9. So my guess is that you just didn't think to do a common denominator as a way to simplify it.
For the most amount of arrows.
I had to go backwards so much because I got stuck on one of the problems. My brain just wouldn't comprehend it, so I went backwards to the thing. So I find a question 20 before I found the answer question. For some reason.
Yeah. Yeah, when I get stuck, I just work random questions and then kind of narrow it down to a couple, and then when I know it's gotta be one of these couple answers, sometimes that's enough of a hint. Just tell me what to do.
So, when you're finding the change of line, is the derivative.
equation of the tangent line?
Yes. So it's,
Well, tangent lines are always linear,
okay.
so I would use point slope.
Okay, so what if the derivative isn't, like, what is x cubed for the
So your derivative is x. So your derivative, make it like this.
I messed up like halfway through, so I answered everything but I messed up on the way. Well, I recorrected it.
The tangent line needs to go through a certain point.
I thought it was the answer, it wasn't. But that answer still existed on the page, so I thought I had it right. Until it moved back around to number one. I was like, oh, you should, well, I'm not done yet.
One for x1, I just use the point. And then the slope's changing over time. That's what this is telling you. So if you want to know the derivative at this time, you're going to plug this into the derivative, and the derivative would be with your hypothetical. And this whole thing would be the tangent.
Okay, thank you.
Can't wait for lunch.
Okay, let me offer to help out with another question or two on the board. Yeah. Hold on, I heard his first. Okay, which one is 14?
The bottom left.
Back page. Okay, so I know at the end I want to know the derivative at 5, but first I need to find the derivative. So k prime of t. Now, if you strictly just memorize the formulas, one thing that's problematic with this is the formulas are set up where f of t would be the numerator and g of t is usually the denominator. That's why I don't like to think of it as that. I like to think of it as u over v. But the product rule, quotient rule, something divided by something, says derivative of numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone all over denominator squared. And when you phrase it that way, it doesn't matter if it's g's or f's or h's or k's of t's, whatever. It still just works out. Now I just want to know, what about at time 5? So everywhere there's a t, I'm actually only interested when t is 5. And they better have given me enough information for all of this. So g prime of 5 is 1/2. F of 5 is 3. F prime of 5 is 3x plus 7. G of 5 is 2x minus 1. And over f of 5 squared, which would be 3 squared. So 3 over 2. And then if we distribute all this, we would get a minus 6x squared minus 3x plus 14x would be 11x times this negative would be a minus 11x. And then negative 7 times a negative would be positive 7 over a 9. And that doesn't look anything near any of them. Cube. Oh, sure it does. Okay, they just split it up. So right here we could, I think we're still on the right track. But if I split apart my fraction here, I could combine 1.5 with 7 to get 8.5 and put that over 9. So if I try to rewrite this, 8.5 is like 19 over 2 divided by 9 is 19 over 18, I believe. 17, sorry. It would be 17 over 18. Okay, if I put this over 9 and reduce it, that would be negative 2/3 x squared. And then if I put this over 9, just splitting apart the fraction, this is how they wrote the answer. They just put it in descending order. This many x squareds, this many x's, and this is your constant. That's how they came up with that as an answer. So I guess the lesson I would try to learn out of this question is harder if you memorize the formula too literally. Think of it as numerator, denominator, derivative numerator times denominator left alone minus derivative denominator times numerator left alone all over denominator squared. If you learn the formula that way, then it's a little easier to tackle. All right, Luke, what did you have?
I was gonna say.
Oh, same one? Okay, did you, is that what all you needed out of it?
Yeah.
Okay.
Well, I combined it with this. 7. Because they're both constants. 3 over 2 is like 1.5. Add that to 7, that was like 8.5. And then I just changed 8.5 back to a fraction.
This is 13.
Jackson is. I always said nothing. I thought you kind of looked like you go to Harvard or Charlotte. Yeah. Oh really? Is he Jackson Home? He's I think my age, I was senior.
Half of it. I got it. I gotta read 61 pages.
The last one, I feel like embarrassing.
You what?
Charge it every night?
No, I got like like 2 bars. I thought it pulled out. It didn't pull out.
So can we turn in the book assignment, like, can we turn that in on the computer?
Or a hard copy. I don't have it open in Google Classroom yet, but I will before next class.
I hand these to you.
Just right there.
Thank you.
It's just a whole bag.
There's not many, there's like 40, there's several, yeah, that's how you get everything. But again, I don't think so. You should watch the videos.
Also, this one, I have a little bit of different numbers for the textbook assignment.
Is it, do you have it as number 20?
Yeah.
Yeah, I think you're right.
Okay.
I misnumbered it once and I think I forgot to update.
Okay.
Oh, that's right. It's blue around it.
What's the circle
A
one?
little bit better.
The hard one?
I gotta read into the window by tomorrow though. I gotta clear it.
Was there
I just suggested that you circle the one. You might look back at it.
Whatever one.
Where's it's all the same thing. It's over the first 10 chapters. It's what? It's pretty interesting so far. Here's a little weird one.
You going to cell group tonight? What?
I'm thinking of some football.
Yeah, I'm sitting in film like all night. This is gonna be like Arkansas and Missouri State there.
Some dude's gonna pull up.
There's gonna be like literally 20,000 people.
We can't even fit like 2,000.
I mean like 10,000. There's gonna be 10,000. We fit 7.
Yeah.
And there's gonna be at least 3,000 people. That's how big it's gonna be.
I'm not thinking of the cell. I just think I get home.
I don't really learn a lot of stuff, but it's like it's good to see everybody.
I know, like, I'll definitely get up second semester. Like, I get home and I still have homework to do. And, like, I don't feel like doing homework, like doing cell and come back to the house like 8:30 and doing homework and you gotta sleep at like 9:30.
Yeah, I'm really just go because I don't get a chance to like see those guys anymore. You know, they're all like, we're all like separate now.
Yeah.
Not the same school. And no one goes to school anymore. Like,
I would definitely go, just so like, it's right after football, like as you get home at like 6:15, and it's just like, I don't feel like I'll sit down for a second.
I got it.
I can do it.
Oh, yeah.
It's cool. I know, I used to start that. I think it's like
Yeah.
Okay guys, we've got about 7 minutes, so I need to make a slight adjustment here. I thought everybody would be able to finish the circuit. If you're working a little bit slower, you're catching on a little bit slower, that's perfectly fine. I will still let you turn in 22 at the start of next class. I will also ask for that long book assignment next class as well. So I plan on opening that up in Google Classroom. It's not opened up right now. But that long book assignment, typically I make most standard assignments just out of 10 points. But on short stuff, I might make it 5 points. Much longer stuff like that book assignment, I'll probably put it in as 20 points. Make sure you have it all completed, not missing anything. Have checked your answers so that you get all 20 points. I do need the book handouts back. So again, those are not yours to keep. So if you are not finished, feel free to keep using your last 6 minutes here. But today's puzzle, have y'all done this yet?
Yeah, we saw that.
Okay. All right, then there's today's. Now you gotta do it fast though.
Red, green, blue, yellow,
Touch
blue, red, green, red, blue,
Fast.
yellow, green, blue, yellow, green, red, blue, yellow, green, blue, yellow, red, white, black.
I said the word originally, I was like, wait, I just.
All right, does anybody think they can do this well enough that you will do it out loud for the class to grade you?
For extra points?
No, not extra points. This doesn't have anything to do with calculus. I'm not gonna Alan, you wanna do it?
I think I can do it better if I just take off my glasses. Because when I can't read it. Red, yellow, blue, green, yellow, red.
How fast do you have to do it?
Oh, so
Wait, you said red on blue, I thought.
red, blue, yellow, green, red, white, black. You got that?
Sir Alan.
Okay, he cheated. He can't see without his glasses.
Hey Alan. You gonna break that state record again? What was your time last year?
No, they were like a day ago. They waited this time.
You gonna break 4 this year?
Like 2 days ago. I don't know. I don't know. I saw news about it. And I was like, what?
I have no idea why. I would already say because
Yeah, but everything.
I don't think
You know what indoor season
They
is?
tell us thousands of dollars. They do it on the
It's in, I thought it was January.
a lot of tracking.
I'm so excited for this year because like I'm gonna be doing every event.
Thousands of dollars.
What all this is.
It's weird.
Yeah, there is one student. I don't even know who this is.
I might do it. I want to see how fast it is. Yeah, but I don't know who that is.
You were in track?
Little kid.
Please don't take my book handouts.
It's not. The first meeting sometime at the end.
I'm the.
I just noticed that I did not have a score on 10, so I'm assuming I never took it.
But we should be sitting here.
I would be mad if they did.
I got to the point where it's on the even, so I don't have the answer.